guys, so today we are going to discuss about HTTP requests and HTTP responses. To understand HTTP requests and HTTP responses, let me explain the client to server architecture. The client to server architecture involves a client, which can be a mobile phone or a browser, making requests to a server. A server is any computer that serves objects to clients. These objects can be files, can be HTML files, can be videos, can be audios, or anything that can be stored on the computer system. So, saying for instance, you want to visit the YouTube website. Your browser types www.youtube.com and the URL. This is a request that has been made by the client. The request goes to YouTube servers, and then the server responds with the YouTube web page. That is it. This request and then response has a structure. In this video, I'm going to explain to you the structure of the request and then the response. To understand HTTP, let's take this analogy. Whenever you want to write a letter, you indicate on it the recipient address and then the sender's address. This letter is then sent to the post office to be delivered to the intended recipient. Good. So bringing this to the client to server architecture, this is how it is. Before the client makes a request to the server, the client has to establish a reliable connection between itself and then the server. How do they make this connection? They make this connection using the TCP protocol, that is Transmission Control Protocol. The client, in establishing a connection with the server, follows what we call the three-way handshake. The three-way handshake involves the client sending a synchronization message to the server. The server then receives the synchronization message and then acknowledges the message. The server then returns the acknowledgement message, of which the client also receives that synchronization and acknowledges that it has received the message from the server. The client then sends back its acknowledgement message, and then the server also responds, making the connection complete. After the three-way handshake, the client can then make a request to the server, of which the server can also respond. Now let's look at the structure of the request. The HTTP request has the following structure. It has a request line and then the header lines. I'm going to explain this in a very short moment. And the request line consists of the HTTP method, then the path to the resource, and then the HTTP version that you are using. This HTTP method can come in several forms. It can be a post, delete, and patch, and then even head. We have several of them. I'm going to just explain the get and then the post. The get, as the name suggests, is used to get a resource from a server. So this resource, as I explained earlier, can be audio, it can be file, it can be like any object that can be stored in a computer system. And so the post method is also used to create a resource in a computer system. Let's say, for instance, you are signing up on a website. In signing up, you enter your details, your first name, your last name, your email, and then the password that you want to use. In this way, you are using the post method to create an account on a server. And then the index.html is a path that you are accessing on the server. So maybe if you have index.html file on the server, you are trying to get that file using this path. So this is what it indicates. And then the http/1.1 tells us the HTTP version that you are using. Great. Now let's move on to the header lines. In the header line, we have the host. Okay. The host enables a request to know the intended server to access. So say for instance, in the access of this host, the server will not know the client's request won't know the server to contact. So assuming this host here is www.google.com, it means the request is supposed to go on Google service. If it's www.youtube.com, the request is for YouTube server. Great. Then the accept with test/html. In this situation, the client is telling the server the kind of resource that he's expecting. It is expecting. So say for instance, it is text/html, meaning the response should be an HTML file. Basically, that's it. And then the user agent. Okay, this user agent is somehow like the client trying to introduce itself to the server. Say, hey, server, this request is being made by Mozilla Firefox version 5.0. Exactly that. So if this request was made using the Chrome browser, it will have the name of the Chrome browser and then the version of Chrome that made that request. So as simple as that. This connection, which is keep alive, is very, very important. I want to be mute on this for now, and I'll explain this to you in a very short moment. Now let's move on to the structure of the HTTP response. Now the HTTP response has what we call the status line as well as the headers. The status line indicates the state of your request. So in this case, the status line has the HTTP version, the status code, and then the status message. The status code tells you the state of your request. Was your request processed successfully, or there was a fault in your request? So if you get a status code such as 200, it means your request went through and then the server was able to respond successfully. A status code like 404 means that the resource that you are looking for cannot be found on the server. As simple as that. So this video is not a video for HTTP status code. So if you get time, just Google HTTP status code and try to understand some of the status code that we have. Now the content type. When the server responds to the client, right, the server automatically, okay, automatically detects the type of response that is given the client. So if the file, okay, or if the response contains an HTML file, then the content type becomes text/HTML. If the response is a JSON, then the content type becomes application/JSON. Now, what then is the content length? The content length gives an idea of the size of your response in bytes. So in this case, and the size of the response is 512, right, bytes, as simple as that. And then the set cookie. Mostly the server uses cookie to identify the client. So say for instance, if the client makes a request to a server, the server generates a cookie, okay, in the response, and this cookie, when received by the browser, is stored in the browser storage. So anytime that the browser wants to make a request, okay, to the same server, it adds this cookie to the request, and in that case the server will be able to know the client making that request. So anytime, let's say for Amazon, when you visit an Amazon website, it generates a cookie for you. So with that cookie, Amazon website is able to suggest to you some product that you want. So cookies are very, very important, and so you must learn how to handle them well. Now the connections, there are two types of connections uh, in HTTP request, right? We have the persistent connection and then the not persistent connection. For the persistent connection, whenever the client connects with the server, right, after the server responds to the client, the connection between them is still maintained. So anytime that the client wants to make another request to the server, it doesn't need to reconnect. It directly makes the request and the server responds again. But in the case of a non-persistent connection, anytime that the client wants to make a request to the server, a new connection has to be established, meaning the previous connection that will be made will be closed. As simple as that. So this kind of connection places a heavy burden on the server when a server has to establish connection for about multiple users, say like 100 users or 1000 users. Wait, how do you know that the HTTP your HTTP connection is a persistent connection or a non-persistent connection? That takes us back to this. When your header contains has this connection keep alive, it means you are using a persistent connection. If the connection here is closed, then it means you are using a non-persistent connection. Let me show you this in my browser. I want to make a request to get, let's say, google.com, google.com, and I want to search for what is a computer. Okay, what is a computer? Okay, I get the search result. So these are the search results that I get. Let me type F12. Okay, for F12, and I move on to the network tab, right? So let me reload the network tab. When there's any request that I make here, okay, this tab gives me all the requests that I'm making. So if I check, if I move on to this side, if I tap on this, if I click on this, I see the URL, request URL. So this is the URL of my request. So this URL contains host, the host, the host name, right, which is play.google.com, and then it has a path. The path is /log, right, and it has some query parameters. This has a request method of post, meaning there was actually a resource. I created a resource on this server. I don't really know. And then the status code gives me the stage of my request, meaning the request went through very, very, very well. It was successful. Let's check some headers here. We have the content length. Okay. The content length tells me the size of the response that I received, and the size of the response was 363. And let me see if I have another one here. So user agent. Yeah, I discussed about user agent. So user agent gives an idea of the client that was used to make the request. So in this case, the client was Mozilla slash 5.0. I'm on Linux, so things could change. Maybe your site to the user agent might be different. Assuming you are using Edge or any other browser, things might be different at your site. And let's look at the response. This was the response I had. Okay, this was the response I had from this request. If I check this request to, if I check the headers here, I think I'm having a different URL, right? So when this request method was get, and if I check the contents, let me see. Okay, let me check if I have a user agent, same thing here. I have oh, I think this didn't have the content length. Let me, so as simple as that. So you can just be checking any request that you make to any server. You can just be checking the state of the request from the browser's console using this network tab. As simple as that. I believe you have learned something from this video. If you want to keep receiving content like this from me, please don't forget to subscribe. Thank you.